We have a box of mass 5 kilograms that is being pushed up a smooth ramp inclined at 10 degrees to the horizontal by a force of 12 newtons. A few important things to pick up from the question here. We have a smooth ramp, which basically means we're not considering frictional forces. It has a mass of 5 kilograms, and it's also being pushed up by a force of 12 newtons. The first question says, find the magnitude of the reaction force acting on the box. Before we do that, let's actually draw the system. I always recommend that when it comes to these kind of mechanics questions, it's always best to see what's going on. So let's draw our horizontal ground. Let's draw our inclined slope at 10 degrees, of course not to scale. So we're gonna have 10 degrees to the horizontal. Let's draw our box. We know our box is 5 kilograms. However, because we're going to be resolving forces, we consider the weight component of the box. So that's gonna be 5g, because weight is equal to mass times by gravity, where g will have a value of 9.8, and that's according to the Edexcel specification. Now we want to consider the other forces. So it's being pushed up this slope by a horizontal force of 12 newtons, which will be acting in this direction here, up the slope. And we also need to consider the normal reaction force of the box, which will be perpendicular to the box. So now that we've drawn on our forces, we now need to consider what the component of the weight will be parallel and perpendicular to the slope. So how can we do that? If we create a few right angle triangles, so if I extend this line down here, where this line is going to be perpendicular to this surface, let's make that explicitly clear with the right angle there. And if I was to extend this line here to create some sort of a right angle triangle, well, that would be the right angle. Very bad right angle triangle, I must say, but should do the job nonetheless. Where this line is also perpendicular to this point here, we can figure out what the angle here is. So that's going to be 180 minus 90 minus 10, which is 80 degrees. That will then help us figure out what the angle here is. I'll put that in red so it's explicitly clear. So that's going to be 90 minus 80, which is 10 degrees. So what we can pick up from this is, well, whatever the angle here is going to be the same angle here. So theta here is equal to theta here. And that will then help us figure out what the component of the weight perpendicular and parallel to the slope actually is. So this line here represents the weight parallel to the slope, and this line here represents the weight perpendicular to the slope. Well, now it's very obvious that perpendicular to the slope is going to be 5g cosine theta, in this case cosine 10, and parallel to the slope is going to be 5g sine theta, or sine 10. So now what I'm going to do is I'm going to redraw the system with the components of the weight parallel and perpendicular to the slope. You can just memorize that these components are sine and cos, they will never change, but this is just sort of an explanation as to how we get there. Now that I've written down all of our known forces, we can now do part I of the question. Find the magnitude of the reaction force acting on the block. Well, in order to do that, it's going to be quite simple. We're just going to be resolving Newton's second law, acting perpendicular to the slope in this direction. So let's do that. Part I. We're going to be using Newton's second law, F equals ma. And let's pick a direction. So I'm going to take the upwards direction as being positive, upwards and perpendicular to the slope as being positive. So that's going to be n minus 5g cosine 10 is equal to ma. One thing to note here is that there is no acceleration in this direction, right? The block isn't moving away from the slope, nor is it moving through the slope. And therefore the acceleration in this sort of perpendicular direction is going to be 0. Therefore, n minus 5g cosine 10 is going to be equal to 0. And as a result, the normal reaction force is equal to 5g cosine 10, which is equal to 48.26. But let's give this to 3 significant figures, so it's going to be 48.3 newtons, and that's 3 significant figures. Let's now do part II of the question, where it says to find the acceleration of the box going up the slope. So they've told us what the direction of acceleration is. This is quite important because I typically prefer to resolve in the direction of acceleration, although it doesn't matter because the sign will tell you which direction the block is accelerating in anyways. So again, let's apply F equals ma. Let's do this in the positive direction going up the slope, because it's better to resolve in the direction of acceleration, although it doesn't necessarily make that much of a difference. That's very simply going to be 12 minus 5g sine 10 is equal to ma. Now we know the mass of the block is 5 kilograms, so it's going to be 12 minus 5g sine 10 is equal to 5 lots of a. We can then rearrange for a, so a is going to be a fifth of 12 minus 5g sine 10. And therefore A is going to be 0.698 meters per second squared. And we can, again, give that to the three significant figures. So I hope that was useful. If you have any additional questions, please leave some comments below. And yeah, see you in the next video.